Hello everyone, we are Group 62. Our project is the text-to-game AI agent. Do you want a game you designed by yourself? For example, the left one, the FPS shooter game, or the right one is the medieval horseback adventure game. So, let's say, or the text-to-game AI agent. Input AI and output. You type the idea, the system build the game parts. We fix the five problems: long time, lot rework, high skill needs, safety, and the high cost. Who benefits? The solo and or the small teams get the model in one day. Big team make the asset packet at the scale. QA or the live ops run one click test and quick rollback. Publishers see the audit ready reports. From the feature map, the flow gets the end-to-end orchestrate, setup, make contents, import to UE5, test, release, and monitor. The yellow block shows the AI story, images, 3D, and the scenes all passing a safety gate. Then the path lead to the UE setup, quick test, and packaging to the Steam and Epic with the analytic. One click run this whole path after you choose the platform.
This slide shows our use case diagram for agented auto game generator. The main function is auto generate, which means one click can build, test, and publish a game automatically. Then we have 10 smaller use case. Use case 2 makes the game idea same and platform clear. Use case 3 sets the art style and quality rules. Use case 4 to 6 create the story, pictures, and a 3D model. Use case 7 checks all the content is safe and allowed. Use case 8 puts everything into Unreal 5 to make it playable. Use case 9 runs auto tests for performance and bugs. Use case 10 uploads the final game to Steam or Epic and adds analytics. Each actor works on their own part so that the whole process is smooth and automatic. Next slide.
Okay, this is our class diagram. The class diagram shows agentic auto game generator designed to automate the entire game creation pipeline. At the center is a game project class, which defines the game concept, parameters, and quality standards. The core of the system is agentic auto game generator, orchestrator. It uses a series of interfaces like iContent generator and iEngine API to manage the workflow. Different users, from producer to moderators, interact through specialized console derived from a base user console. Okay, so the next is our object diagram. The object diagram provides a snapshot of the system generating a specific game project called Neo Rogue, which is a cyberpunk roguelike. We can see concrete instance of our classes at work. The content generator is actively creating assets like a 3D model of a hiker and the story content. The entire workflow is managed by the agentic auto game generator. It orchestrates everything from UE5 integration and automated testing to the final build and development stage. Okay, let's look at our system architecture. First, the structure class diagram shows our main auto game pipeline components. It highlights its internal parts like the content generator and the UE5 integrator, and its internal pods for everything like story generation and engine integration. Next, we have two collaboration diagrams. The content pipeline shows the workflow from content generation and safety checks to testing and building. Finally, the collaboration use diagram ties it all together. It illustrates how the main auto game project use both the content pipeline and release flow.
We framed our system's architecture using the Cruton's 4+1 model. The logical view defines our key domains: an orchestrator, content generator, safety, UE5 integration, and a platform gateway. The process view shows how this works in practice. We use parallel workers for generation and safety scanning, which feeds into a fully automated pipeline of UE5, import, build, and test. Physically, the system runs Kubernetes with elastic workers and connects to external AI services to deploy On platforms like Steam, this enables our key scenario one-click policy-driven game generation with safety gates and auditable releases. Next slide. And next, the activity diagram shows the end-to-end flow. It starts with a one-click trigger after designers set parameters, early safety scan blocks, or diverse risky content for human review. If content passes, it's automatically generated, imported into UE5, and build. Automated tests then act as a gate. A pass moves the build to a staged rollout with live monitoring, while a failure triggers an immediate rollback. Next slide. Finally, the interaction overview shows how services communicate. The UI sends a request and orchestrates or content generation with AI models. Approved assets are stored, then pulled by the UE integrator for building and testing. Based on the test results, the orchestrator either deploys the game or guarantees the build. Next slide. Next slide. And the remaining slides are deeper dives into this say interaction. That's the end of the interaction overview.
Now I will cover the behavioral and the structural modeling part of our system. So which covers the state machine package and deployment diagram. Starting with the state machine diagram, we model a workflow across all 10 use cases. There are 5 diagrams in total, each combining 2 related use cases to represent a full content pipeline generation. It starts from the concept drafting and approval, then moves into the parameter freezing and narrative generation, followed by the asset and 3D model production, safety, and the UE5 integration, and finally testing and releasing. Next slide. Each state defines key transition like a proof concept, start narrative, or retry integration, ensuring the AI agent handles user input and the validation steps systematically. This event-driven structure let us trace every possible outcome from success to failure or review each state. Next slide. The package diagram shows how the system is modularized. We grouped components into logical domains such as core orchestration, content generation, integration engine, safety and moderation, testing, and then release and platform. This modularity improves scalability and makes it easier to maintain or extend individual subsystems. Next slide. So finally, the deployment diagrams illustrates how everything runs in practice. It maps these packages into physical nodes, like client interface, cloud-based LLM server, build service, and the database cluster. This layout supports distributed processing, secure data handling, and efficient cloud deployment for our text-to-game AI agents. Thank you.
Thank you. That's all our presentation.